So here I am going to deliver a lecture on convolutional neural networks. The prerequisites for this lecture, including for theoretical understanding, we require basics of artificial neural network, which includes perceptron architecture, activation functions, multi-layer perceptron, forward propagation, backward propagation algorithm, and some other basics. Then, for implementation purpose, we require Python programming skills, libraries including NumPy, Pandas, Matplotlib, Keras, TensorFlow, etc. You can also use another programming languages. So here the content is of convolutional neural network, in short CNN. Introduction, CNN architecture, its layer-wise details, which include data input layer, convolutional layer, with the process description and example, pooling layer, with the different kind of functions like max pooling function, average pooling function, with the flatten layer description, dense layer description, and at the end, implementation of basic CNN using Python programming. Introduction. An artificial neural network, in short ANN, are general purpose neural networks. It composed of interconnected layers of neurons. ANNs may struggle with tasks requiring where understanding the features with the spatial hierarchy is required. A convolutional neural network, in short CNN, is a specialized class of neural networks, particularly designed for processing spatial hierarchy features understanding from a grid data. For example, from an image, want to access what are the different colors like red, green, blue, three basic combinations we are getting used. Then CNN able to understand features with spatial hierarchy by identifying how pixels in a grid data or in an image relate to the neighbors. This highlights certain visual elements of 2 and 3-dimensional datasets, like depth in an image, like color in an image. So these are the kind of spatial hierarchical features. A CNN is particularly powerful in computer vision applications, such as image classification, image recognition, object detection, scene understanding, etc. CNN architecture is basic representation of convolutional neural network. Here we are presenting a basic architecture only. So here data input layer having width, height, and channel as a 3 parameters, where in some cases image of grayscale form or image of black and white form have width and height only. There is no channel included. Or we can say in short, one channel included. Whereas in image with the RGB input, we have 3 channels images, like of to define 3 different colors. Then output of data input layer is fed into the convolutional layer, where the filters, kernel size, activations are the major parameters to understand. Then the outcome of convolutional layer fed it to the pooling layer, which includes pool size, strides as the parameters. Then the outcome of pooling layer fed it to the flatten layer, which is having no major parameter. It is just replicating all the 2-dimensional or 3-dimensional data in a one single dimension or sequence. Then the outcome of flatten layer is getting input to the fully connected dense layer, which includes units or activations. So it could be differ. Units could be differ according to the flatten layer, or activation functions, different activation functions could be applied, like sigmoid, like ReLU. So these are the basic already covered in the artificial neural network for activation functions, like sigmoid activation functions or ReLU activation functions. So the outcome of the fully connected dense layer is again fed to the output dense layer. So this is the final layer which is going to outcome generation for either in a binary outcome or in a categorical outcome. That depends upon our classification method. So next through PPTs, we are going to discuss layer-wise details for each and every layer and its operational principle. Then first layer, data input layer. Here, this layer is providing data to the CNN architecture for training and testing purpose of CNN model. Commonly, the input of the 4-dimension is required to operate programmatically. Like here we're taking N, W, H, and C, 4 different parameters, where N is the number of images, W is the width of image, H is the height of image, and C is the channel of image. For training a convolutional model, we require the number of images to train of same width, same height, and same channel. So channels may require in terms of RGB image, we are using 3 channels. In terms of black and white or grayscale image, we are using 1 channel image. Height and width will be according to the image size. Then the data input for the different shapes, for example, 2-dimensional image could be represented with the width of 2 pixels, heights of 2 pixels. In short, we say 32 into 232 pixels. Whereas 3-dimensional image could be represented with the width of 32 pixels, height of 32 pixels, and 3 number of channels. In short, we say 32 into 32 into 3 pixels. For example, here 6 into 6 image I have created for black and white pixels, where black pixels are representing 1 and 0 pixels are representing the white space. So here 6 into 6 array of 0 and 1s is being created as a input. So this input is further fed to the convolutional layer. So in terms of convolutional layer, it is a backbone for your CNN architecture. The convolution layer is responsible for extracting features from the input data by utilizing the convolutional operations. So 3 major features, major parameters we need to work on, that are filters, kernels, and activation functions. These are the 3 key terms which we need to work on for convolutional process of a CNN layer. Then filters particularly are used as a feature detectors. These are capturing the specific patterns like edges, textures, or more complex features. Then multiple feature maps are getting generated using multiple features and creating an aspect of the outcome. Then kernel is a matrix, which is a slide across the image. And multiple kernels are getting applied to enhance the outcome. Then activation functions, as earlier in artificial neural network as a prerequisite, activation functions are basically a threshold algorithms or a threshold mathematical functions, on the basis of which they are generating the outcome. So activation function is simply a mathematical function which helps the neural network to learn a non-linear relationships. So majorly we are using sigmoidal, ReLU as an activation function in CNN layers. Then you can see here the convolutional layer process description. First block is showing input data with the width W, height H, channel C. Whereas next layer, convolutional layer, is representing F number of filters. I and J is the kernel size. It is a matrix. Kernel is just a matrix over here, which is going to define in 2 dimensions, that is I into J. S are the strides. Strides have a specific operation we are going to discuss in very next example. Then AFN is the activation function as discussed. Then next is it is generating the outcome of F in C, number of outcomes it is getting generated, of shape W N and HN, because width and height both are getting changed once we apply convolutional layer. Now in example, we can consider the further description where the input data with width 6, height 6, and channel 1 is applied. As we have taken here the input, this is of width 6, height 6, and channel 1. Similarly, the process through the convolutional layer is 2 filters I am applying. Filters could getting applied number of filters, right? Here we are using 2 filters for easy understanding. of shape 3 into 3. So kernel is defining the shape of the filter. And stride is 1. So how stride is working, that we are going to work. Then AFN function we are using ReLU, that is rectified linear unit. So here the operation of rectified linear unit could be like, it will become 0 on any value, but it become 1 when it found some threshold. So that depends upon ReLU operation. Now, next presentation includes convolutional layer process. You can see here 6 into 6 images getting input as a convolutional layer for the convolutional layer, and 2 filters we have applied here. So these are the randomly generated filters. If you apply 32 filters, your convolutional layer will randomly generate 32 filters, so that it should extract the different aspects of your image, right? So now here we are applying my 1 minus 1 minus 1 minus 1 1 minus 1 minus 1 minus 1 1 is a filter 1, and another one is a filter 2. So 2 filters we have taken here. Now here we have defined that each filter have 3 into 3 kernels, right? Now next convolutional layer process includes of application of filter 1 to the image. Now it is just creating a dot product on the selected kernel. So here this red unit is representing the shape of kernel. So here the shape of kernel is applied as three into three. That's why it is representing here this red selection of an array. So firstly, it selects this red selection of an array and applying this filter 1. Once it apply a filter 1 in the form of a dot product, so it generates. So one example I'll like to explain here. See, by applying this one multiple with this one in terms of dot product, then applying this minus 1 with multiple of this 0, applying this one with multiple of this 0, by applying this one with this one, applying this one with this one as a dot product, applying this one with this one. At the end, it sum all the outcomes. So if I apply 1 with 1, that is 1 plus 0 with minus 1 is 0 plus 0 with minus 1, 0 plus 0 with minus 1, this one 0 minus 1, 0 plus 1 plus 0 plus 0 plus 0 plus 1. So its outcome is 3 in total. So here it is resulting 3. Now you can see here we have taken a stride 1 as a parameter. So in terms of stride 1 as a parameter, it defines how this array is getting moved to the next selection of kernel according to kernel. So here, if the stride 1 is there, so it is going to skip the first column and then it is going to select this array. Now you can apply again here the filter operation and apply a dot product. So it is going to generate outcome minus 1 again. Now if what happened if we take stride is equivalent to 2, now you can see once we are applying the filter 1 on using stride 2, so it is selecting the first as similar to the stride 1, but once it is making shift, it is making shift by skipping the 2 columns over here, then making shift by 2 columns over here. Now we are going to discuss the outcome of stride 1 for simplicity and better understanding. So here the outcome of stride 1 is 3 minus 1 minus 3 minus 1, and similarly this is the outcome. Now you can see whenever you're applying the stride is 1, so it is reducing the image with the shape of, if the image input is 6 into 6, it is getting reduced by So it is resulting you 4 into 4 as an outcome. Because it is going to skip one from this row wise column wise and one from skipping one from this column wise. So it is getting reduced 2 by 2. Now you can see the outcome which is getting generated by our convolutional layer process where filter 1 has been applied on the image of 6 into 6 and generating outcome of 4 into 4. Now, when we applied filter 2, so again the same process is getting applied and the outcome is getting outcome is getting generated by repeating the same operation. But the outcome is different because the filter is different. The operational outcome is different. The operation is same, but filter is different, so the operational outcome is different. Now we have 2 4 into 4 outcomes. So the outcome here of this is 2 4 into 4. Here we have mentioned. This is called a feature map, means the extracted features by the convolutional layer. Now, the next process of convolutional layer, if we have RGB channel, now we have the 3 different images, not only single image. If the channel is 1, so image is single. If the channel is 3, 3 different images are there of same height and shape. And when we apply different filters, same filter to different filters on these 3 images is definitely going to generate the 3 operations over here for RGB, 3 operations over here for RGB. Whereas earlier we are applying 1 operation only for filter 1, 1 operation only for filter 2. Now, the pooling layer process description. The outcome of convolutional layer is fed to the pooling layer. It is a combination, and pooling layer is combining the multi-dimensional array into a single dimension for compression. It reduces the image size and outcome of that image size without losing the featured characteristics of that image. Why we are reducing? Reason is when we have less number of elements to operate, neural network is less complex. If we have more number of elements to operate, neural network is more complex. So pooling layer reduce the dimension of your input data. Generally, we are applying 2 into 2, 3 into 3, and 4 into 4 kind of pooling parameter for operation. So 2 type of pooling functions are there: minimum pooling, maximum pooling, average pooling. So generally we are using maximum pooling as a function operation. Then stride having the same operation in the pooling layer also, but here the parameter is again is getting defined by the number of pixels by which the jump applied on more pixel, more operation pooling operations per pooling operations. Now here generally we are using n into n pooling size, where the n is the considered as the stride in the pooling layer. So shape and strides is having n value only. Now the outcome of pooling layer we are going to discuss. Here we are applying the max pooling function. This is the actual image. This is the filtered outcome, filter 1 outcome. Now this filter 1 outcome is getting applied on the pooling function. So here convolutional layer converts the 6 into 6 data into 4 into 4 data, and 4 into 4 data fed it to the pooling layer. Now 4 into 4 data input applies with the maximum pooling layer function and converts into 2 into 2 data with the pooling layer parameters. Here the pool size we are considering 2 into 2 and strides 2 as 2 different parameters. Now you can see here, if the pool size is 2 into 2, so we are selecting here the 2 into 2 array. Now again, here max pooling function is getting applied, which means the outcome of this selection is the maximum value. So here the maximum value out of 3 minus 1 minus 3, 1 is obviously 3. So here the outcome is 3. Similarly, In next selection, we have strides 2. So it is going to skip 2 consecutive columns and shift it to here. So now here the outcome, maximum outcome is 0. So here the outcome is 0. Similarly here, it is going to shift to skip 2 columns because strides are 2, and here is selection, and skipping 2 columns, here is selection. So outcome of 3, 0 and 3, 1 is getting resulted. So this is the outcome of pooling layer. Now, if we have multiple features as an input, then multiple pool outcomes are getting generated. Now we'll see. Now here the average pooling function is getting applied. For example, similarly the input is same, the filtered outcome is same, and now when we apply averaging, so average of 3 minus 1 minus 3 1 is 0. Minus 3 minus 1 my 0 and 3 is 2. Similarly minus 2 and 1 is getting out. Now we are discussing about multiple filters which are generating multiple outcome in convolutional layer. So if the multiple features are getting generated, similarly the multiple max pooling outcomes are getting generated. So here the according to the features or according to the filters, we have 2 filters. So outcome is 2 into 2 array, but with the 2 different arrays getting generated. So ultimate outcome is 2 into 2 into 2 array with the shape. So here, this is example which is representing multiple convolutional operations with the max pooling layer. Now, the role of flatten layer. It is simply used to connect CNN to dense neural network to find and identify the complex patterns and making predictions. So it is just taking input of multiple pool outcomes like filter 1 pooling layer outcome, filter 2 pooling layer outcome, that is of shape 2 into 2 and 2 into 2. It just converted into a sequential outcome like 3 0 3 1 minus 1 1 0 3. It is a sequential outcome, and at the end the flattened layer outcome shape is 8 into 1. Now the next layer is dense layer and its description. So dense layer is working similarly to the parallel layer of neurons. It is used to classify data based on output from convolutional layers. Dense layer is a kind of a final neuron. In terms of binary classification, we are using one single neuron. In terms of categorical classification, we are using multiple neurons as a final outcome. So generally, sigmoidal and 10H functions are getting applied for finding activations at the dense layer. Now, the combination of multiple dense layers are getting applied for creating a more or multi-dense neural architecture for provide better predictions. Then activation function, here we are applying sigmoidal function as an outcome. Now you can see here this is the input which is getting generated by this flatten layer, 3 1 0 1 and so on. So this is the input generated. Now this input is getting fed to the summation function. So generally dense layer have two operations: a connected network, fully connected network with a summation function, which is making sum of all the inputs, including weights also. So the basic operations of weights are already getting described in our artificial neural network prerequisites. So here, if I'm saying the weight of each layer is 1, each neuron is 1, so the outcome could be 3 plus 0 plus 3 plus 1 plus minus 1 plus 1 plus 0 plus or minus 3. So it is the summation, it results 4 as the outcome. So this summation outcome is fed to the sigmoidal function. Generally, the sigmoidal function is working like this as shape outcome, where it will get activated when you are providing some threshold value. And it is ultimately resulting, if the result is greater than this summation is greater than 0, then it results always 1. If it is less than 0, then it results -1. So here the input is to the sigmoidal function is 4, so it generalized in outcome 1, means activated. Now, further, we are going to understand the same process by implementation of CNN using Python programming. Here we require IDE, where we are using Python development utilizing IDE Spider 4.0, then Python programming interpreter utilizing version 3.7.4, and other respective libraries of current version. So here I have already coded one operation. Now I'll show how this library you can use for CNN application, and you can understand how a layer-wise layer outcome is actually produced. Now, here I require the NumPy as a basic library for matrix operation, matplotlib as a basic library for visualization operations. Keras is the basic library for neural network implementations with the backend of TensorFlow. So this TensorFlow is Google platform library. So here we have different layers, including like models, layers, sequential operations, load image functions, image to array conversion functions, then matplotlib we already applied. Then the basic models and layers we require to import. Now, here we initialize a model with the sequential. So this is the basic function to initialize a Keras model. After that, we are adding a layer by layer operations over it. So firstly, model.add, we are firstly need to add the convolutional layer, which is of 2D, two-dimensional layer. Here, this 8 is number of filters. How many filters you want to apply? You can apply accordingly, according to your data set. That is, you can analyze your data and you can vary accordingly. Then, this 3:3 is the kernel size. Here we are using strides 1:1 and activation function ReLU over here. And input shape of my data or image I am getting used is 150x150 of 3 channels. Second, after that, I am applying here the max pooling layer, where the pool size I am applying 2:2 with the strides 1:1. Then I apply a flatten layer. It is having none parameter to input. Then I am applying a dense layer, which is getting a 1 binary outcome, and the activation function is sigmoidal over here. I just compiled out with the binary loss cross entropy. So loss is a function which is going to train your model, which is allowing to train your model in backpropagation neural network forms or concerns, which is the base as a prerequisite. So similarly here, the binary cross entropy loss function we are getting applied. Then I have created one function to explore your image, which is taking image path, which is input as an image, and this model which we compiled out. Now, here the first operation we need to apply, load the image, where we provide the path of that image, and the target size which we have is 550x150. We are converting 3-dimensional image into 2-dimensional only, so easy to understand. Now, here we are just displaying the image with its dimension. Now we convert this image into an array, and now we apply some basic processing concepts. Here, we are identifying the layer by layer outcome from this model layers function and the name of each layer to better understand, and just here displays those names using the print function. Each layer have an activation model. We already displayed, which we already discussed, like first layer over convolutional layer have ReLU, then we have sigmoidal. So we are just extracting the activation of the model outcome as a outcome. So here the predictions are getting applied on the given input. So prediction is just representing the outcome of this prediction is representing how an image is getting displayed, okay, or an image is actually displayed after a layer by layer operations. So this a looping structure is applied for applying or resulting the layer by layer outcome. Now, I just compile this above code and created a model and initialized the function. Now I have a model with me, not a trained, it is just a dummy initial model with me. So I have a model with me. Now, an image path is available. So I just applied. Now you can see here the outcome of this image that I will explain. Now, undock this image. Now you can check. I applied this image as an input where the shape of image is 0 to 140, 0 to 140 as an input after first layer, pooling layer. Now you can see here the features are extracted after this convolutional layer, then pooling layer. Now you can see the difference, how the features are getting extracted. Now these are the highlighted features over here, which are getting understood by this convolutional layer. Similarly, if I applied this same operation on another image, now you can see here, this is the dog image. And now this is the outcome of first convolutions, now the pooling outcomes. You can see here how the image is getting displayed over here. Now, okay. Now, I would like to show you the outcome of this layer wise. See here, the shape of first image is 148 into 148 into 8. Then the shape of another max pooling is 147 into 147 because stride 1 we have applied here, right? And the prediction of image, it is generating 0.51. So that initially here, till this point, we just describe the layer wise outcome only. We have not utilized as an application for classification or prediction. We just explore how each and every image is getting displayed and result. So thank you. Thank you very much for listening this lecture. Hopefully this lecture will help you